Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, IIT-Jam, Jest and other exams related to physical science. Okay, so this is the lecture number 35th of mathematical physics, and this is the last lecture uh, of the subject. Okay, and in which I'm going to discuss a green function. And also guys, I would request the student who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay, so I'm going to start green function guys. Okay. So green function. Meanwhile, just let me check whether I'm audible or not. Then I'll proceed further. Lectures which, yes, I'm audible, so I'm going to proceed further. Okay. Okay. So guys, green function, it's an important topic. Okay, and 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 you will get a 5 marks question in CSIR net. So, if you will solve the questions related to green function by proper method, then it is going to take a lot of time, guys, and you have limited time in your examinations. Okay, so what I'm going to do is I'm going to tell you the trick that by that trick you can easily solve green functions questions. Okay, and I'm going to explain that with questions, guys. Okay, so question number first. Okay, question number first. Question number first is the green function. The green function. The Green's function. It is Green's function. Okay. Green's function. Green's function. Green's function G, which is function of x naught for for the for the boundary for the boundary value problem. For the boundary value problem, that is d2y over dx square plus 2 dy over dx equal to fx. Okay, in x greater than 0, with the boundary condition, with the boundary condition with the boundary condition with the boundary conditions, that is y at x equal to 0 equal to dy over dx, y at y, which is function of x equal to 0. Okay, that is 0. This is the boundary condition given. Okay, and is. Okay, so options are given, guys. So option number A is, that is, I'll write in next page. Okay, option number A is, option number A is 0, that function. Okay, that is 0 for 0x. Okay, I can write like this will be better. That is g, which is function of x and x naught, right? That is equal to 0 for x is between 0 to x naught. Okay, and the second is 1 by 2 into 1 minus e to the power 2 x naught minus x for x greater equal to x naught. Okay, this is the one option. Option B is Green's function x naught is going to be 0 for 0 greater equal to x naught. Okay, and then 1 by 2 1 minus e to the power 2 x minus x naught for x greater equal to x naught. Okay, this is option B. And option C is g, which is function of x naught, that green function. This is 1 by 2 into 1 minus e to the power 2 x minus x naught for x is between x and x naught. Okay, and then 1 by 2 into 1 minus e to the power 2 x naught minus x for x greater than x naught. Okay, and option D is g, which is function of x naught. Okay, that is equal to 1 by 2 into 1 plus e to the power 2 x minus x naught for x is between x to x naught, and 1 by 2 into 1 minus e 2x minus x naught minus x. Okay, for x greater equal to x naught. Okay, so these are the options, guys. Okay, so question is the Green's function. We need to find out that that is g, which is function of x and x naught, for the boundary value problem d2y over dx square plus 2dy over dx equal to fx in x greater equal to 0 with boundary condition. This is okay. So so we need to select, these are the Green function given, and we need to select the correct option. Okay, right? So this is the Green's function we need to find out for the boundary value problem. This okay. So how to solve this Green function problem by trick, that's I'm going to explain. Okay, I'll solve multiple questions of Green function, okay, using that trick, and that is very important, guys. Okay, and you can easily solve these questions very quickly by using trick, and this type of question you will get off 5 marks in CSIR net. Okay, and if you if you will start solving these questions with proper method, that is going to be very lengthy, guys, and this will waste your lot of time. Okay, and because in your examination you have limited time. Okay, so I'm going to solve it by trick. Okay, so we have been given this boundary value problem, right? We have been given, so I'm going to solve it. Solution. Okay, so we have been given due to this one. Okay, d2y over dx square, d2y over dx square. Okay, and then plus 2 dy over dx plus 2 dy over dx. Okay, and equal to fx. Okay, equal to fx. So this is the given, right? Okay, for using trick, what you need to do is, for using trick, so this differential equation may be anyone, right? Anything. So for this first of all, p naught x, that must be 1. P naught x means the coefficient for using this trick. Okay, the coefficient of d2y over dx square. Okay, so coefficient of d2y over dx square should be 1. So in this differential equation we can see there is the coefficient of d2y over dx square is 1. So we can use green function here. Okay, we can use the trick for solving the green function. Okay, so d2y over dx square, so that should be 1. Okay, coefficient of this should be 1. So first what we'll solve this equation in three steps. Okay, first we will check continuity. Okay, first we will check continuity at x equal to x naught, because here function is this one, g x naught. If in case of it is g t, instead of in question you can get the green function which is function of x t as well. Okay, if there is t instead of x naught, then it is going to be at x equal to t. Okay, first we will check continuity. Okay, continuity. Second we'll check boundary conditions. Okay, boundary condition that should satisfy the boundary condition. Okay, so satisfy boundary condition. I'm writing in green, that in red. Okay, it will be very important. Okay, satisfy boundary condition. Okay, satisfy boundary conditions. So second order differential equation. Okay, you will solve by green function. So satisfy boundary conditions. Okay, number third is what we are going to do is we'll find del g. Okay, we'll find del g over del x. Okay, del g over del x at x equal to x naught positive. Okay, x naught positive. Okay, that is greater value for greater value of x. Okay, so this is x equal to x naught plus. Okay, x naught plus minus del g over del x at x equal to x naught minus for less value of for lesser value of x. Okay, so and that we'll check this and that should be equal to 1 if any green function, right, satisfy these three condition. Okay, for satisfy this condition is must. Okay, so the coefficient of d2y over dx square must be 1, and then these three condition. Okay, if green function, that function satisfies the continuity, if it is continuous and it satisfies the boundary condition, and then that del g over del x at x equal to x naught plus uh, minus del g over del x at x equal to x naught minus equal to 1. If this value is equal to 1, then that function will be the green function. Okay, and that function, that will be the correct answer. Okay, okay, okay. So this one. So now we'll solve question using these three conditions and we'll get the answer. Okay, so for solving this type of green function, what we are going to do is we will solve a green function by options, guys. Okay, we'll use this trick in options, and whichever option will satisfy these three conditions, that will be the correct answer. Okay, so for this function we have these four options given of green function, right? We'll check one option by one option. Okay, one by one we'll check all the options, all four options, and which option, the option which will satisfy these three conditions, will be the correct answer for the question. Okay, very simple. Okay, so we are going to check first option. Okay, first option. First option. Okay, so we have this one, right? First option. So first we'll check. So first option is we have this first option. I'll write this. The option is this one. Gx naught. Okay, right. Okay, option is g, which is function of x and x naught. That is going to be that is 0 for x greater equal to for x is between 0 to x naught. Okay, and 1 by 2 into 1 minus e to the power 2 x naught minus x. Okay, for x greater equal to x naught. Okay, so this is the greater value, right? This is the lesser value. Okay, so this is the one, right? This is the option A, guys. And now we'll check if this option satisfy these three conditions, means then this option is the correct answer for the question. Okay, so and we can see here in question, right? This is the differential equation, right? And we have to find out the green function for this, and we can see that P naught x equal to 1. So we are good to go to use this trick. Okay, well, so first we are going to check continuity. Okay, continuity. Okay, continuity. So suppose so now we have to check all the option one by one. Okay, if first option is not correct, then second, then third, and fourth. So any one of the option will definitely be the answer. Okay, so continuity, we are checking continuity. Continuity. Okay, continuity. So what for continuity? What we do for continuity, guys? This is we'll check this. Okay, continuous. This function should be continuous at function should be continuous at x equal to x naught, right? So we'll put so here if you put x equal to x naught, this value is already 0, right? So this is the continuous. For this we'll check it. Okay, so like this one 1 by 2. So we'll put in this in this uh, in this expression x equal to x naught. So we are putting, okay, 1 by 2 into 1 minus 2 x naught minus at x value we are putting x naught, right? X equal to x naught. That should be 0, guys. So let's see what value it is giving. If it is 0, then it is continuous. Okay, so this is going to be 1 by 2 and e to the power this x naught minus x naught means 0, right? So this is 1 by 2 1 minus e to the power 0, right? If you subtract x naught from x naught, this is going to be, so this is going to be 1 by 2 into 1 minus 1. So e naught value is 1, right? 1, 1, 0. So this value is 0. And the first value is already 0, right? It means this function is continuous. So, okay, it means it's continuous. Okay. So first condition is satisfied. Okay. It is continuous. It is continuous. Okay. It is continuous. Now we'll check second. That is boundary condition. Okay, boundary conditions. Okay, and that must satisfy boundary condition. Okay, So boundary condition is this, guys. I will show you. This is given. Okay, why not? Y value of y at x equal to 0 should be equal to value of dy over dx uh, equal to 0. Okay, y at x equal to y at x equal to 0. Okay, so this one. So we can see this is all, first is already 0, right? This, and second will be also 0. So we can see boundary condition. So this will also most of means all these options will satisfy this boundary condition, right? Okay, that is going to be y at x equal to 0 is going to be d over dx y at x equal to 0. This is going to be 0, means this is satisfying the boundary condition, because we can see here the first value is already 0, so we don't need to put y equal to 0, right? So this is already 0. If you differentiate it and uh, put x equal to 0, so this is also going to be this value d over dx at y dy over dx or dy at x equal to 0 over dx is also going to be 0. So this is satisfying boundary condition. All the options will satisfy boundary condition. Okay. Well, so the boundary condition is satisfied. Now third is the most important one point, guys, and because most of the option you will see continuity, the continuous this condition, continuity and boundary condition will be satisfied. On the by third we will be able to check whether that is the correct option or not. Okay. So now what we have to do is del over del x del over del g over del x at x equal to x naught minus del g over del y at x equal to x naught minus and x naught plus. This is for greater value, this is for lesser value, and that value we have to check. If this value is 1, then this would be the correct option, guys. Okay, so this is the g, we'll differentiate it. Okay, so this is the lesser value, guys. Okay, this is the greater value, so we'll do it. Okay, so this value is 0, this is greater value, because this is x greater equal to x naught, right? So this is the greater value, so x equal to x naught plus x naught, my apology, this is x naught plus. Okay, so now we'll differentiate it. So this value is 0, right, and this 1 by 2, so del over del x, g value is 1 by 2, this is greater value, x equal to x naught plus means greater value. Okay, we'll write greater value. So 1 minus e, 1 by 2 into 1 minus e, 1 minus e to the power 2 x naught, e to the power 2 x naught minus x, 2 x naught minus x, 2 x naught minus x. Okay, x naught minus x at x equal to x naught plus minus this value is 0, right? This is g, right? This is the lesser value, so this is 0, so we'll directly write 0. Now we'll differentiate it, right? Okay, now we are going to differentiate it. So if you differentiate it, so this is going to be, guys, 1 by 2. Okay, this differentiation is 1, right? This is 0, guys. 0 minus this is going to be e to the power 2 x naught minus x. Okay, x naught minus x into differentiation of this is going to be minus 2. Okay, minus 2 minus 0. Okay, this value, and this value is going to be, see, this is 1 by 2. Okay, and this is now we'll put at x equal to x naught. Okay, x naught, if you put x equal to x naught, this is going to be x naught minus e, this is going to be e to the power 0, right? So this is going to be minus minus plus e to the power 0 means value 1, right, into 2, right, and 2 will get cancelled, so this value is 1. So we can see this value is 1, right? So it means del g over del x at x equal to x naught plus minus del g over del x at x equal to lesser value, right? X naught minus is equal to 1 implies g, this one, option A, right? Satisfy, it satisfy g x equal to x naught, g x equal to x naught satisfy all three conditions. Okay, all three conditions implies g x equal to x naught is a green function, is a correct answer, right? This means option A is the correct option. Option A is the answer. Okay, so this is the answer, guys. Okay, so option A is the correct answer because it is satisfying all three. This is continuous. Okay, at x equal to x naught, and these boundary conditions are satisfied. And third is this del g over del x at x equal to x naught plus minus del g over del y at x equal to x naught minus value is 1. So it means the option A is correct. In case suppose option A is not correct, right? If doesn't satisfy all three conditions, then we'll check option B. If that is also not correct, then we'll check option C and option 4. Right? Any one of them will be the will satisfy the all three conditions, and that will be the correct answer. So so for this trick is very important. Okay. So for this question, right, the green function x naught for x naught this for the boundary value problem this with the boundary condition this is, so for this question the correct answer is option. Okay, I hope guys you have understood it. Okay, okay, well, now next question we are going to do. So we'll use this trick, guys, very important. I have written in red. Okay, and we'll solve questions, guys. Next question we are going to solve, and that is asked in that is a CSIR net question, guys. Okay, question 2, CSIR net. Okay, so this is CSIR net question. Okay, question is this one, d2y over dx square equal to fx. Okay, fx, and x belongs to 0 and 1, means x value is between 0 and 1. Okay, and y0 equal to y1, y0 into y1, right? That value is going, that is 0. So this is the boundary condition given, right? And options are given, option. So this is the green function question, guys. So this is the differential equation given, and x is between 0 to 1. Okay, and the boundary condition is given for this problem. Boundary condition is given y0 and y1 equal to 1. For this problem, you need to find out the green function. Okay, and options are given. So we'll check one by one option and using the trick. Okay, very important, guys, because you will get the you are getting this question in 5 in CSR net of 5 marks. Okay, so well, options are, option A is g green function with x and d. Here in place of x naught it is given t. Okay, that doesn't make any difference. Okay, so this value is x t minus 1. Okay, and where x is less than t. Okay, second is tx minus 1, tx minus 1. Okay, and where x is greater than t. x is greater than t. Okay, so this is the greater value, this is the lesser value. Okay, this is important too because we will use this in third condition. Okay, okay, so this is the option 1, and option B. Option B is g, which is function of xt, is equal to x t minus 1. My apology, that's not correct. So this is x square t minus 1, and x for x less than t. Okay, and this is x square, which is okay, so this is t square, guys. T square, which is x minus 1. Okay, okay, and this is x greater equal to t. Okay, so this is the greater value, right? Okay, next option C is that is g, which is function of xt, that is equal to sin x into t minus 1. Okay, and this is for x less equal to t, and the second is sin x t into x minus 1, which is x less than t. Okay, x greater than t, this is x less than t. My apologies, x greater equal to t, right? X greater equal to t, x greater equal to t. So these are the options, three options I'm writing. Okay, so this is the CSIR net question, guys. Okay, simple. This is the problem given d2y over dx square equal to fx, and x is between 0 to 1, and boundary condition is given. For this problem, we need to find out the grain function. Okay, so we'll use again we'll check option by option, one by one option, and if whichever option is going to satisfy the three boundary conditions, okay, that will be the correct answer. Okay, okay. So now, so these three conditions I know. First, we'll write this problem. Okay, so this is uh, d2 since given, right? d2y over dx square, d2y over dx square equal to fx. Okay, fx. This is the question which is given. Okay, d2y over dx equal to fx. So here we can first will check the p naught x must be 1. P naught x means the coefficient of coefficient of d2y over dx. So we can see this is 1, right? So now we that should be that must be equal to 1. Then we will use that trick, guys. Okay, so now we are going to use trick. There are three conditions, right? First is we'll check continuity, guys. Okay, and we are checking one by one. Okay, so first option, we are checking first option, guys. First, okay, first option, that is g, that is g equal to g, which is function of x and t, g, which is function of x and t, that is x, which is a function of x t minus 1, okay, x less than equal to 1, x less than equal to t. Second is x minus 1, okay? Tx minus 1, Tx minus 1, x greater equal to x greater equal to t, x greater equal to Okay, so this is this option we are checking. So first we are going to check continuity. Okay, three things we need to check: continuity, boundary conditions, and that del g over del x at x equal to x naught plus minus del g over del x at x equal to x naught minus, that should be equal to 1. Okay, so now we are checking first continuity. Okay, first condition is continuity. We are checking continuity. Continuity means, right, we'll put in this equation x equal to t. Okay, 1 second, right? Okay, okay guys, so yeah, okay, so now we have written some that is option incorrect, guys. So option is like this is t, guys. Okay, this is t minus 1, and this is t minus 1. Okay, x minus 1, this is x minus 1, this is t, this is t, guys. Okay, well, mm. So first we are going to check continuity. Okay, continuity. So this is going to be, guys, one axis, and we'll put this one this way. This one continuity at x equal to x naught. So for value of x, we'll write x equal to t. Now continuity, putting x equal to t. Okay. So we'll put the x equal to t. So this is going to be this is the condition, right? X equal to t. Yeah. First one is x equal to t. Just wait, guys. Let me just check. Continuity. So we'll put x equal to t. So this should be equal, guys, right? Not 0, equal or 0, right? So this is x, guys. So we have made some mistake here. This is x. So we'll put the value, okay? That these two values should be equal, guys. Okay, that is the continuity. If these two values are 0, that is also equal, right? Okay. So this is x. So now we'll put x equal to 0. Then this function, green function, is going to be x. This green function is going to be g, which is function of xt. We'll put x equal to t. Okay. This is going to be, first is going to be t into t minus 1. Okay, and it is x less equal to t, and the second term is going to be t into t minus 1 at x greater equal to 0. See here, you can see both term are equal, right? It means this function is at x equal to t. Both term are either both terms should be equal, right? If it is 0, if it is 0, then it should be 0, right? Right? If it is same, and this should be the same, right? The first one is t into t minus 1, and second is t into t minus 1, right? So that implies it is continuous. First condition satisfied. Continuous. Okay, first condition is satisfied. Okay, now we'll check boundary condition. Second condition. Okay, so it is continuous because putting at x equal to t, we are getting same value for first and second. Okay, I hope you have understood it, guys. Okay, next, second is boundary condition. Boundary condition. Okay, boundary condition. Boundary conditions. Okay, so we have this green function g, right? We have this green function g, which is function of x and t, right? This is x t minus 1. Okay, and second is t x minus 1. Here x is less equal to t, and here x is greater equal to t. Right? This is the green function. Now we are checking boundary condition. Boundary condition are given y0, this y0, y at x equal to 0 is 0, y at x equal to 1 is 0. Right? So what we are going to do, we'll put y at x equal to 0 for this, for first function. Okay, so we'll put x equal to 0 in the first function. Okay, so first boundary condition, this boundary condition is for the first term, and this boundary condition is for the second term, right? Okay, so this is the first term, this is second term. So first we will check y, right? Y at x equal to 0 for this, and then second we will check y at x equal to 1 for this. Okay, so we are checking y at x equal to 0. Okay, y at x equal to 0 means we'll put in this function x equal to 0. So this is going to be 0 into t minus 1, and this value is 0. Now we'll check y at x equal to 1, y at x equal to 1, y1. Y1, the second boundary condition for second term, first boundary condition for first term. Okay, so y, so in this term we'll put x equal to y at x equal to 1, right? X equal to 1 will put. So this is going to be t into 1 minus 1. X value in place of x we have put 1, right? 1 minus 1. So this is 0. So it means y0, both value are 0. Y0, y at x equal to 0 equal to y at x equal to 1, y at x equal to 1 equal to 0. So boundary condition is satisfied. Okay, BC, boundary condition satisfied. Okay, so second condition is also satisfied. Now we'll get third condition. Okay, condition third that is del g over del x at x equal to x naught plus minus del g over del x at x equal to x naught minus. This value will find out. Okay, this is the third condition. So this value is going to be, we'll put, okay, del z equal to del g upon del x at x equal to x naught plus means greater value of g, right? So this is the greater value, right? Because this is for great x is greater than t, right? And this is the lesser value. So we'll write this value first. Okay, so this is going to be del upon del x. G value is this kind of, okay, t into x minus 1. T into x minus 1. Okay, at x equal to x naught plus. Okay, x naught plus means the greater value, greater term. Okay, minus, this is going to be del over del x, this value, this is the lesser value, right? Less than x is less than t, x into t minus 1, x into t minus 1 at x equal to x naught minus. Okay, x naught minus means a less value. Okay, now we'll find value, so we'll differentiate it. This is going to be t, right? And x equal to x naught, this value is going to be t if we differentiate it. Okay, because tx, this will be 0 and this will be 0, right? We know simple differentiation. Minus here, this is going to be t minus 1, right? t minus 1 at x equal to x naught. So there is no x, right? X naught. So we'll solve it. So this value is going to be t minus t plus 1, right? So this value is 1. So we can see this value del g over del x implies del g over del x at x equal to x naught minus del g over del x at x equal to x naught minus, this is x naught plus, this value is, this value equal to 1, implies third condition is also satisfied, right? Third condition is also satisfied, means now guys, very simple. So we have this question given, right? This question is given, right? And we have to find the green function for that. So we'll check one by one option, right? So we started with the first option, right? And we have checked this one, the continuity. For continuity, both if we put x equal to t, both terms should be equal, right? And we can see this term is, and if when we put x equal to t, both term are equal, it means this is continuous, right? Second, what we have done is, second, we have checked the boundary condition gt. This is the green function, right? So this is for first term, this is for second term. So we have put y at x equal to 0, and we have put x equal to 0 here. We've got 0 value. Again, we have put x equal to 0 for second term. So x equal to 1, we've got the same value. Means y0 equal to y1. The boundary condition is satisfied. Now third is this one. We have to check this third condition, right? This one, del g over del x at x equal to x naught plus minus del g over del x at x equal to x naught minus, right? And that value must be 1, and we have got this value 1, means this g is satisfying all three condition. It means A is the correct option, right? I hope guys you have understood it. Okay, very simple, and I have tried to explain it as simple as I can. Okay. Okay, so this one. Okay, so option A is the correct option, guys. Okay, next, one more question we are going to solve. One more question. Question number third. These are long questions, guys. Okay. This is asked in December 2018, guys. Okay. So question number third is asked in CSIR net. CSIR net, December 2018. Okay. Question is, the Green's function, the Green's function, the Green's function g, which is function of x and x dash, here x dash, okay, x dash, for the equation, for the equation d2y over dx square, d2y over dx square equal to fx, for this. Okay, with, okay, this is the same question, guys. Okay. Is it the same one? Let me check. Yes. Okay, so this is the same question, guys. Okay, so this is the question which is asked in December 2018 question, guys. Okay, December 2018. Okay, so this is the same question, guys. So this is not going to solve this one, because this is the same question. Okay. Okay, so these are two questions I have solved, guys. So this is the trick you need to note down. Okay, very important trick. Okay, and you can easily solve these questions, guys. Okay, so I have solved two questions for you, and just what you need to do is now you can try solving green functions questions using this trick. Very simple. Just there are three tricks you need to use: that continuity, boundary conditions, and that condition, that del g over del x at x equal to x naught minus del g over del x at x equal to x naught minus that should be equal to 1. And or always make sure that in differential equation, that the coefficient of d2y over dx square should be 1, and then you will use this condition, guys. Okay. Okay, so guys, this is about the green function, right? I have told you the trick, and now you can easily solve green functions questions using this trick. Okay, so this is the question which is asked in December 2018, guys. Okay, and also when I'm solving PYQs, right, of 2020 and 2021 also I will solve. Then all the PYQs I'm going to solve, and there will be many questions of green function, and there also I will solve the green functions questions using this trick, guys. Okay. Okay, guys. So now this is the 35. This is the lecture number 35 of the mathematical physics. Okay, and now mathematical physics is completed, guys. I have completed mathematical physics in 35 lectures, guys. Okay, well, guys, also I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live classes which are going to help you to crack the exams related to physical science. Okay. Okay, guys, thank you so much. Bye now.